Okay, in this lecture I'm going to show you just a few examples. I'll also show you a couple of things that I have not talked about before. Now it's kind of difficult because there are quite a few things that I cannot show you at this point that I'll have to show you in Module 102 once we've covered pointers and references. And because I talked about how it is a contiguous block of memory basically, but I haven't really shown you in more detail on a lower level what that means. So in other words, how it works with the memory addresses and stuff like that. But for right now, we are mainly concerned with how we can actually store data in an array and get data out of that container as well. Hey, so just a quick note before we get into this, I'm actually recording this note here after recording most of this lesson. And you'll notice that I #include C standard library and also C time at the top. You don't need those, you only need IOStream for cout, cin and so forth, and then also the standard namespace. We won't be using anything in those headers in this video. It's actually something left over from another video from the previous lesson that I decided to move over to Module 102. So a bit of an error on my part, so I'm just highlighting it. Putting it in won't actually do anything, but you don't need any of that to use arrays. You don't need any special includes or anything like that to use arrays, alright? You'll actually see me remove those at the end of the video. So here, just as a quick demo, I have an odd array of integers that has 5 elements, 1, 3, 5, 7, and 9. Here I do cout, odd array, and I pass it the index that I want to go and fetch. So 4 will be, in this case, the final one actually, so 9. We start at 0, 1, 2, 3, 4. So this should print out 9. Build and run that and you can see that's what we get. Similarly, if we do 0, we get 1, okay, as we might expect. We can store data in an array like this. Of course, I don't have any string, so it's just going to expect me to enter a value. So I'll do 5, and it's going to give me 5 back if I press enter. So you might want to do something like this. Cout, enter an integer, cin, odd array, and in this case I'm passing index 0, which is the first element. So even though I initialize this odd array of 5 elements of type int to 1, that first element is 1, I'm going to change it here. So Ctrl F5 to run that, let's say 5, and you can see it gives us back 5 instead of 0. Okay, so here's the problem. We have 5 elements. Let's say we do 5 here, right? You have to remember, if we do it this way, we are passing the index of the element that we want to access. This is different than the declaration, so the size declaration. So this is out of bounds because 5 is not in here. We have 0, 1, 2, 3, 4. So if I do Ctrl F5 to build and run this, you might get warnings and so forth. In this case, we don't get any of that. So what you could get is a crash instead. So I'll do 5, and you'll get some corrupted and, weird errors. So I'll do abort, and you can actually now see, instead of exiting with code 0, the program now exits with code 3 instead of code 0. And in the output, we don't get any errors or warnings or anything like that. But in the error list, you can see you actually get a few warnings that might be useful. So you get index 5 is out of a valid range 0 to 4. So this is useful. You get some warnings. You might want to check this before you actually build. You don't actually see anything in here. Okay, so go do and check the error list. See, if you hover over here, you'll get some information as well. You'll get this green squiggly line. But the point is, the program still runs, right? It doesn't give us an error, but still it is going to crash. So there's no automatic out of bounds checking. We have to do that ourselves. Set this to 4 and this will work fine. This should clear up now. Yeah, I can see that'll clear up. Alright. That often takes some time to clear up. Okay, I'll just comment this out here. And what I'd like to do now is I'd like to print out an element that is not initialized. So let's say I grow the size of this odd array. Let's say we have 6 elements, and I go and print out 5. So even though this is declared to have a size of 6 elements, we only go and initialize the first 5 elements. Now, as an exercise, I'd like you to try and figure out, maybe write in your notes what you think will happen if I run this code. Type it in, and try this before we continue. Okay, I'll just go ahead and build and run this. And you'll see we actually get 0. So that has to do with the list initialization. This also, by the way, works without the assignment operator. You can see what we get 0. So basically it's going to declare this array, odd array, that has 6 elements, and they're all going to be integers, right? So they're all going to have that size. The ones that you specify or initialize will have the values that you initialize, and the rest will simply be 0. So let's just take all of this stuff out actually. Control F5 to build and run, and all of them will now be 0. So even if I do 0 here, Control F5 to build and run, we'll get 0. Okay, so for purposes of the next section, I'll go and write a for loop. So int I is 0, will loop whilst I is less than 6, and with each repetition once again I'll do I++. Then I'll go and copy this. I'll go and copy and paste that in, and I'll do I right here. So 0 to 5. And you often use the less than, so I less than how many elements you have, so the array size, so we have 6. So as long as I is less than that, or less than your array size, or n, where n again is your array size, then go and continue to execute. Control F5 and you can see that we get 0 in there. Put those back and you can see what you get. So once again, that final element will be 0. Now you might think if you go and do something like this, so we have 1, that all of those will be 1. But actually it's just the first one that's 1, right? The other ones will be 0. So I might have given that away a bit in the video, in that example. But again, if you have the first element initialized to, let's say, 1, if you only have one element in that list initialization, it's not going to give all of the elements, that initialization. So it really depends on what you go and add. And you have to go and initialize each element individually, basically. Okay, so I've removed that list initialization, so this is just the declaration. Build and run that. And now you can see we get all of these weird numbers. Again, this is rubbish, basically, and is not very useful. That's a similar problem to when you do something like int x. Now, if you go and try and build and run this, you'll actually get an error, which is very handy. You can see the error here, uninitialized local variable x. So that contains garbage, right? So that's why I keep saying that it's a good idea to go and initialize your variables before you use them. So if you don't have a specific value right off the bat that you want to use for your variable, a good idea will be to go and use the curly brackets. Of course, what you can do is you can give it a value like this. So this is one way of declaring and initializing a variable. So you can see 5 and the rest is just garbage. But if you don't have an initial value to give it, what you can do once again is you can use the curly brackets. That will initialize it to 0. Okay, 0. And that's basically the same thing that you get with an array as well. It also uses this, is called or referred to basically as a list initialization. It's typically used with a list, and you can see instead of having garbage in for those data elements, you now have 0 instead. That's much easier to use for debugging purposes as well. So I just wanted to demonstrate that. At this point, this array will have 0 as all of its elements. I'll do another for loop here, and so we'll start with 0, and then we'll do 0 plus 1 is 1, and so on. So once again, you can use for loops to initialize an array or to change existing values within an array. So currently, those elements are all 0, and now we'll go and change those, and here we'll print them out using another for loop. And you'll see what we get. We can go and give these a few values. So I have not defined the size of this odd array. I'm simply declaring it, and I'm giving it the list of elements that I want it to contain. And basically I'm shifting the workload for this onto the compiler to calculate the size of this array. And in some cases that can be very handy. But you have to make sure to update. So currently we have only 5 elements. So we need to go and change this here to 5. And those are our values. Actually, this is probably more or less what it should look like, since this is an odd array that I'm using for demonstration here. You can see that works fine. Okay, I'll do a bit of cleanup. Just go and delete all of this stuff. I realized that I included these two, so cstandard library and ctime. You don't need those, you don't need anything special, special include to work with arrays. Those were included for another video that I worked on that covered random number generators, and I actually moved that to the next module, so module 102, for various reasons. And somehow I forgot to clean that up, so again, all we need here is the IOStream and using namespace standard. Alright, so getting back to arrays, you can actually do something like this. So this is fine too. Right, so this might look weird if you have it like this. Something like that. It might look weird when you have only the array name and the opening and closing bracket, but this is fine. We are declaring that as an array of integers, and you can go and declare them along with other integers. I probably will not do it in this way. Most likely I'll have this on its own line, so each array declaration, just to make it easier to read and to find between everything else. So this will work fine. You can see this will build. Don't get any errors really. We don't use anything in this case, so I'm just going to remove that. And okay, let's say you want to do something like this. You declare a temp array of type int, and you want to give it like a user-defined size. So you can see I pass it x. You can already see these squigglies. If I go and build this, we'll get an error. So the expression must have a constant value. So you can pass it a variable, alright, to go and declare the size of the array, but it needs to be a constant. So let's go and do that. Let's go and create a constant variable here. And I'll just copy and paste that in. If I build, this will work fine. And now, of course, what we can do is we can pass it the array size. And I'll just go and do something like this, as we've seen before. Okay, so this works fine. I just wanted to show you a couple more things that you might see, some of the errors that you might run into, especially as a beginner, or some of the problems that you might run into. Okay, so a bunch of things that I wanted to demonstrate in this video and in the previous video as well. Once again, there are quite a few more things that I'd like to talk about in Module 102 once we have discussed pointers and references. But we are not quite done yet. We can talk about a few more things in this module. We have another method of looping through the elements in the array, so we'll talk about that a bit later. And we also have multi-dimensional arrays, which basically allow us to create tables of arrays, so we have rows and columns, for example. So I'll talk about that in upcoming lectures as well. Once again, I hope you find this useful, and I'll see you in the next lecture.